Okay, we're on part 2 of this video. We're going to finish number 5 and 6. You're going to skip 7. So here we go. Let's go ahead and graph this right away because you can see that y is already isolated. So my slope is right there, my y-intercept is right there. So you're going to begin at 1, 2, 3, 4, and you're going to rise 2 and run 1. Rise 2, run 1, rise 2, run 1. And of course the opposite of going up and right is down and left, down and left, down and left. Continue as far as you can go, like so. Now this other one we need to isolate y. So to get y by itself I got to get this to cancel, and I can do that by adding 2x to both sides. And when I do that, those cancel and I end up with y equals 2x minus 1. And again, there's your slope, there's your y-intercept. So you're going to begin this graph at -1. Then you're going to do actually the same thing. You're going to go down 2 and right, up 2 and right 1, up 2 and right 1, up 2 and right 1. And you might be noticing something about this, that these two lines are never going to intersect. So, where then are you going to write an ordered pair like this? Well, if they don't intersect, what do you think the solution is? If you drew these graphs from a Tom and Jerry cartoon, would Tom ever catch Jerry? And the answer is he wouldn't. They would never catch each other because they have the same slope. They have the same slope. So the answer is no solution. And you knew that. No solution is the answer. When they have the same slope and they never touch, it's no solution. Let's do our last one on this page. Number 6, you got to isolate y. Subtract x, bring it down, y equals -x plus 3. Subtract 3x down here, and you end up with 3y equals -3x plus 9, but y still isn't quite isolated yet, so we need to divide everything by 3. Y equals -3 over 3 is -1x. 9 divided by 3 is 3. So here are my two equations that I'm going to graph. First of all, do you notice anything about these two? Aren't these two equations the exact same line? Well, when you have this, a same equation is the same equation, you're only going to really graph one line, which is going to begin at 3 and go down 1, right 1, down 1, right 1, down 1, right 1. But the trick is, if you're trying to graph both of these equations on the same coordinate plane and they're actually the same equation, what you have is two lines right on top of each other. This line and this line are really right on top of each other. So if they're the same line right on top of each other, how many places do they actually touch? If I drew one line and then backed up and then came back and drew another line, how many points did they actually touch? Well, guess what? The answer to this is infinite solutions. They touch everywhere because they're the same equation. So that's the answer to that kind of a problem. When they're the same line, they're infinite solutions. Go ahead and turn the page to 23, please. And as you can see, you're going to skip number 10. You can cross that out. Oh, by the way, while you're at it, go ahead and turn to the homework and skip the same type of problem there, which is number 7 on the homework. You don't need to do that one. So on page 25, you're going to skip number 7, and back on page 23, we are going to skip number 10. Okay? Now it looks like we have a lot of work left, but these are going to go quickly. So you're going to draw an example of a graph that represents different outcomes. So one solution is just like this, where Tom catches Jerry. So to draw an example of one solution, just draw two lines that will intersect anywhere. So maybe right there, for example. Boom, there's a solution. The two lines intersect, you have one solution. all you need to know is that they have different slopes. If they have different slopes, they're going to touch. What are we about no solution? Just like we did on this example. No solution means that they have what? No solution means that they have the same slope, which is m. So I'm going to draw a line, maybe let's see, we start here at 0 and go up to 6 and then down to negative 6. So if I draw that line, there's one line. I'm just making up a line here. It doesn't matter where I draw it. But now I want to draw a line that's not going to intersect that. So if I maybe move over 2 and go up here and here, so just move over twice, that line is going to have the same slope, but is it going to have the same y-intercept? No. So the same slope, but a different b, or y-intercept. Okay? And infinite solutions, all I'm going to do is just randomly draw a line, and then I'm going to thicken up that line, because infinite solutions are the same line. Easy. Last set of problems, just like your homework. So when you get to your homework and these instructions are there, just follow these examples. Without graphing, so you don't need any graph, you're going to determine whether it has one solution, no solution, or infinite solutions. Okay? So look at A. Look at their slopes. This is 8. This is negative 4. So do they have different slopes? Yes. The answer is one solution. These lines would intersect. These have different slopes, so the answer is one solution. Look at B. They look very similar. Oh, I have a problem. Is y by itself yet? We have to isolate y again. So subtract 2/3 x from both sides. And now you got y equals negative 2/3 x plus 1. Now what do we notice? Slopes are the same. So since negative 2/3 is the same as negative 2/3, if we have the same slope and a different y-intercept, the lines are going to be parallel, so there is going to be no solution. Okay, letter C. Again, we got to isolate y. So subtract 2x, y equals negative 2x plus 8, y equals 2x minus 2. Those look very similar, but they're not the same. So 2 and negative 2 are different, therefore there is one solution. Negative 2 is different than 2. Different slopes means it's going to intersect. Last 3 problems. Let's take a look at this. Subtract x. Y equals negative x plus 5. Here we got to add 2x. Negative 2y equals 2x minus 10. But y still isn't by itself, so we got to divide everything by negative 2. Now we got y equals 2 over negative 2 is negative 1x, and negative divided by a negative is positive 5. Here is the equation. Here's the equation. What do you notice? Aren't they the exact same equation? If they're the same line slash equation, if they're the same line, the answer is infinite solutions. Last 2. So we subtract 3x, 2y equals negative 3x plus 5, divide by 2, y equals, what you see is what you get, negative 3 over 2x, plus, I don't care if it's yucky, just leave it, 5 over 2. And this guy, minus 3x, we get 2y equals minus 3x plus 6, divide by 2, y equals negative 3 over 2x plus 3. What do you notice about these two slopes right here? They are the same. The y-intercepts are different. This is a 3. So the answer is no solution. Last problem. Y is already by itself, so don't have to mess with it. Here we got to take away 4x from both sides. Bring down what's left. Negative 2y equals negative 4x minus 10. Divide by negative 2. Y equals negative 4 over negative 2 is positive 2x plus 5. This equation and this equation, what do you notice? They are the same, therefore infinite solution. If you need to back this up and do it again, please do so. Rewatch it as many times as you need to. Let me just emphasize something. Every problem we had to do that first. First, you have to isolate y. Okay, take your time. You should have plenty of help available in terms of the video and the substitute teacher. Good luck on this, and I will see you next class.